Hi everyone, welcome to my session. My name is Sandip Pani, and today we are going to discuss about a very interesting topic, which is data leakage. So, as I mentioned here, if you see, it is most ignored problem in machine learning, the data leakage. Why? Because it is not just because people ignore it. The reason is that people can't find out that it is there is really a data leakage issue. So, with that, my name is Sandeep, as I already mentioned, and I work as a principal engineer with NextGen Healthcare. I'm also the regional mentor and the usual lead for data platform gigs. I have more than 14 years of experience in various data platforms. I speak in various global conferences as well as local user groups. And my specialization is into data pipeline design and machine learning, query tuning, and performance optimization. I love to talk about data and I write blogs here in the below link. And also my Twitter handle is mentioned in your screen. So with that, let's start today's session. Today's agenda is like this, that first we'll try to understand what is data leakage. And this data leakage is nothing to do with data breach or something the business data leakage happens from one business, it goes outside. This is data leakage is related to machine learning. In machine learning project, how the data leakage happens and what are the different problems we face because of that, and then where it happens in the whole machine learning project lifecycle or in a data science lifecycle project. And we will discuss with some more examples to understand it better. And then we'll try to also discuss that how we can avoid that. And we also try to see a demo that how it works and how it impacts our machine learning model if any data leakage is there in my data during my model design. So here the data leakage, also called as target leakage, is basically nothing but what happens in this. If you look into this structure or this image, uh, we usually collect the data. Like in the whole business, what happens? We have all our past data with us, and we try to predict something in future, how it gonna happen, or how my business will behave, or what is the event I wanted to predict based on my past data. So past data has everything. So if you look into this timeline, uh, let me take that. So this is my whole timeline, and this is the business. Think about one process started from here. So this is my data started gathering here, and you start keep get entry or gathering the data till this timeline. So this in this particular life cycle, the data may change, or there are various things happens, and something in your business process from one particular point you wanted to predict the future. You have this data and you wanted to predict the future so that you can take necessary action for the future things. So for that, you are going to design a model. So prediction is here, but we already have this till data is from here to here. It's very much important that we need to think that which data I'm considering to design my model. So while designing my model, the data what I have, sometimes we use some data which is not available during prediction time, and that goes to my data for the designing the model or train my model. And that time you contaminate, a kind of contamination you do, or you make some impurity to your data, and that's causes data leakage. And your the model what you design, it won't perform well in production. Yes, of course, it will work very well in the test because you already given some information to this. And that's why when you design the model, this model would be work fine in the training set, it will work very good in the test set, but when you apply to the production, so the model will not perform well. So that's basically is called as data leakage or target leakage. So what are the different problems? The first and foremost problem is it's very difficult to detect this kind of problem because the practice what we do that uh, we just need to avoid this kind of situation. What we do that we split our data into train and test, and we try to think that test data is my unseen data, and I try to evaluate my model using test data. But the certain practices what we follow during designing a model, even if you're not following that particular practice properly, you may do some data leakage to the training set, and there the problem happens. So leakage, and because of that your model definitely is not a very good model. It looks good during your training and testing time, but it is not really a good model. And because of that, the model will really behave very inaccurately, or the model prediction would not work as per the expectation what you are thinking during your testing time. It won't work the similar way in your real life scenario when you deploy that. And if it happens, if the model doesn't work well, then there is definitely loss to the business. And it depends on what kind of business it is, and what kind of decision you take. If it is just something related to healthcare, then it might be life threatening also. So this is really the problem with the data leakage. So to proceed further, I would really like to explain you about predictive modeling. Of course, you guys must be knowing what exactly predictive modeling is, but let me reiterate that, and let me try to explain what exactly the goal of predictive modeling is. So think of what we do. We have all our data. We wanted to predict the future, right? That's what the prediction we do. But the toughest thing is when I'm working on this model, I really don't know what is going to happen in future. To be very honest, nobody knows about it, right? We just try to think of whatever happened in my past, looking into that experience. I try to predict that what exactly can happen in future. It might not happen also. You may do everything perfect, but some kind of diverse event may happen and your model may not work. Say, for example, you have not think in one aspect that you have not done any kind of mistake. There is no data leakage. There is nothing happen in that way, or you have done absolutely every practices you follow, whatever is required. But this pandemic changes this pandemic what is going on right now. It is right now impacting whole predictive modeling mechanism, right? The business modeling, the way the customer behavior, the way the world is going, everything has changed. So whatever you have designed, whatever it was working, and it is not working as expected in my production because the scenario got changed and nobody predicted a pandemic is going to come. So these are some scenarios which we don't know, and we can't avoid that, right? So the moment you know that, definitely you need to rebuild your model based in the customer experience. And till that you're not getting the behavior of customer, you cannot design a good model in that way, right? So with that, the the toughest thing is here is, as I said, the future. Nobody knows that. It is unseen to anybody, right? So and what we do for that, to replicate that future behavior or the future thing, what we do, we whatever data we have so far in the past, we keep some data as unseen data. We have never seen that, right? And when my model is designed, we try to use that unseen data, things like it is my future. We try to simulate that like it is a future data I'm not aware of, even model is not aware of, and try to check if this happens, then how it is behaving. And that's how you try to find out the accuracy of the score and how it is behaving. And for that, to make our model more generalized, we use various techniques like your cross validation, or some other techniques like oversampling, undersampling. We try to make our data more robust, and try to ingest some kind of noise to the data. The only intention is to make our model more generalized, so it should not bias for anything, and it should predict well in my production system. So so how will I know that? We understand that data leakage cannot be we cannot find out, and people, as I said, that this issue happens during your training and testing time, and you will only realize when it goes to production and it is not behaving well. So how can I detect it? Yes, you can detect with some. If you see your model is too accurate, you can't believe that. So what I mean is that, okay, suppose you design a model which is accurately, the model score is like 99.99% and it is looking very perfect. So that time you start thinking of, is it really this model is that much accurate? And then you start, it might not be, the problem may not be, but it is a good starting point to think of when your model is giving you a good score, and you need to check that exactly it is a really giving good score, or is there any leakage happening. Why I'm saying that? Think of a leakage. So if somebody score in an exam 100 out of 100, there are two reasons, right? Either the person has prepared well, he learned everything and he knows about every question and is answering. The other one is that he might be knowing the questions, right? The question leakage. So the question, he is already aware of what question will come in the exam, and he is now writing that. In both the cases, people will get 100 of 100, right? So we don't know which scenario it is. So it's better, just because we are doing machine learning, predictive modeling, we can start thinking about that. Is it a leakage or is it just really performing well? Example, your stock price prediction is super high, and there you may think of it's an so it is very difficult to accurately predicting the stock price. You may go closer but not be pretty much closer. So, and also this problem happens in your very complex data set. So when you have a very complex data set, there is a probability of data leakage. Why? Because it is very difficult to understand if you do not have really depth knowledge of the about the business or the domain knowledge. So be careful when you're working with data set which is very complex. uh, Look into all the metadata, look into where the data is coming up, look into the timeline, how it is coming up, look into how the changes is happening. So you don't know that where this data is coming from. When I said when the data is coming from, think of a scenario. Most of the, in some cases, suppose you are using your data warehouse as a source to get your data. Now, suppose the data warehouse system is implemented with a slowly changing dimension one. It means it never stores any future past history. It just maintains one record, and the same record keep getting changing, right? So whenever you collect the data is the most recent information, and you don't know that the most recent information you will really get during your prediction time or not. And so some columns, one column might be keep changing, right? In the first stage, the value is X, second time it is Y, and third time it is Z. But you wanted to predict Z, and if the Z is already there, it means there is a leakage to that, right? So you are going to predict Z when the value is Y. Will it gonna happen Z or not? It will happen Z or something happen A. So you need to really draw the line that if you're using this kind of data set data warehouse, you'll never find that X and Y for every record. Some record will have Z, and that causes the data leakage. So we need to check, we need to filter out only the data we're having only X and Y. So that's how you need to think of. It can happen. This is one of the scenario. The other scenarios are like, as I said, time series data set and the graph data set we have. So if you try to do random sampling, it doesn't make sense to your time series data or the graph data, because there is a sequence, and you cannot do, while doing random sampling, you may pick some future data which you really don't want to pick that. And we try to design the model. It means you're already getting the data to your training time. You know that what is going to happen in future. So the random sampling can happen from the past data or future data, any time of the timeline of your data set. So what I said, that if you, the point is, if you see the super high accuracy your model is predicting, it's a good starting point to start thinking about whether is it a problem with the data leakage or not. So the data leakage is, or the target leakage is widely categorized into two types, with we call as a feature leakage or a target leakage, and the other one is your train test contamination. So feature leakage is nothing but one of my feature. It is a column wise leakage. It means there are certain columns which is looks alike of your target column, but you do not think that, okay, it is really giving me something, some value which is really pretty much similar to my target column. And examples are duplicate labels. Maybe you are trying to predict something with some column name with a different column name, and this with a duplicate name, it is already present in your trend set. So you're already having that value with you. And in the trend test contamination, it is like a row-wise leakage. When I talked about random sampling, there it happens, or the, because you are splitting the data into trend and test, but some rows are coming to your trend data, which might be same record is present in the test data. Or premature featureization. Premature featureization happens in your during your feature engineering process. So we will discuss one by one. So before that, as I said, how will you know that at what stage this problem occurs, so that you may be more, you will try to give more importance to that phase to avoid the data leakage. Well, this problem can happen at any stage of your machine learning process. It may happen in the data collection, it may happen data preparation time. As I said, it can happen during your feature engineering time, when you're doing feature extraction, or while doing the partitioning, it can happen, or maybe when you're doing evaluation. or during your training and tuning time also. At any stage, there is a probability or there is a chance that you may leak some information to your model while training it. So let's look into some examples to understand these things well. This is the one of the example of data collection. You collected the data like your employee ID, employee name, primary skills, secondary skills, experience, monthly salary you have. And this is the data set we have. And you really wanted to predict annual salary. That's the problem is. And when you collect, you see there is a monthly salary column and you wanted to collect that information. What happened there? So, and you wanted to predict annual salary. But do you think really we need a predictive model? Even though you design a predictive model, it will be super accurate. Reason behind, you already have a monthly salary column, and that talks to you, that is telling you that okay, this is somebody's person's salary is, if it's $6,000, you just multiply with 12. There is no need of prediction. So in this case, you should not collect this monthly salary. And if you really wanted to, because that information will not be having with you, because you wanted to predict the monthly salary of 1,000 people for your company, where have they now joined it and what will be the different trends. You may need to collect those kind of information. If you know the monthly salary, you then there is no need of predictive modeling. And if you're doing the modeling using this column, it's a leakage, and you're giving some information to the training, to the during the training time, to the process to okay to predict it. So there is no use case of this, because in production you may not find this scenario. Now the other scenario is, I have a customer ID column, location column, order ID column, and amount column. I wanted to group different customers based on their aging, based on their age. So I have categorized into young people, adult people, and the old people. So because what I want to do, once I do the categorization, I may start doing my recommendation based on their category. It's like a clustering, right? And if I'm doing that here also, can you predict or can you tell me that where this leakage can happen with this data? Well, if you see this in the customer ID, they are generating the data when they get the information about a particular person, the customer when is doing the registration, based on the age they assign a customer ID. So if it's a young, or whatever may be the age, I'm not talking about the age, but they might have some logic that if this person's age is below this, then I assign them Y. If the age is between this to this, then I assign A. And if they're old, then I can assign O. And the rest of them, it goes through different random numbers. But if you look at here, if you wanted to predict that, this customer ID is giving you this information, and it just by some doing some kind of text uh, manipulation, I can really find out this information, and really I can get the category. I can predict it, and really I'm not using any kind of you know any kind of analysis, and rather it will just look into this and it has that information. So what you need to think of when you're collecting the data, rather get rid of this customer ID column, rather try to get some other informations, right? Like the spending, how they do, whether they earn or not, whether they are working or they are student, or those kind of information may help you more to categorize the data, and that gives you better information because you'll try to learn from that. So let's now think of, this is another example of data collection, and this is problem I picked one from the internet while reading different one of the research paper on how to detect the COVID patients. So what they have done, it is not a real life scenario, but it was a research. They have collected all the COVID patients X-ray as a positive set, and they mixed with some other X-rays as a negative set, like the pneumonia, and they wanted to predict whether that if I give one X-ray to predict that whether that X-ray is a COVID patient or it is not. So surprisingly, when they train the model with deep learning, um, some different network they have used to design the model to learn the image, and they found that their model was 100% accurate. Then they started thinking how come it is predicting that much accurately this X-rays. And after further analysis, they found that whichever the X-rays having this L, if you see these two, those are your COVID patients X-rays. So what internally system learn is, the model learn is wherever it finds L, it predict as a COVID. Instead of learning the whole X-ray, it's just look into this image, and if you find this letter, and it is predicting. So actually you are giving some information to the model, and it just try to check that. In real life scenario, you may not find that L. You have an X-ray, you can give it. Anyways, it's a research paper, but this is what happened. This is also kind of data collection issue. When you're collecting, you make sure that you do not have this information in your X-ray or in your image data set where it gives you some information to know about it. So that way it will perform very well in your training time, but in production, it won't work. So in the feature engineering stage also happen. Think of, you get your data set and you find there are lots of missing values. Of course, you apply some kind of imputation technique, missing value imputation. You use any kind of logic you have. Suppose, say for example, it's simple. I just use a mean for missing values. I get for that column, I calculate the mean and I apply all to the missing columns. And then I split my data to train set and test set. And then I train my model with the train set and I evaluate my model with my test set. So here, where you think the problem is? The problem here is this stage. This stage, what you have done is you get the data. This data is not yet splitted, and with the whole data set, you try to find out the mean. And this mean considering some values which is really not present during your prediction time, because here you try to, suppose now think of, this is my timeline, this is my whole data set from this to this, and I wanted to find out and this is my, suppose this is my test data. I wanted to split, but before split, what I have done, I have suppose value like 1, 2, 3, this missing, then here 4, 5, and then this 6. So, and here some missing values are there. So now if you're trying to find out the mean, what will happen? These are, take the average of all these values. But you don't want to consider these values because this is not present during your future information line. So what you need to do, that you need to find out the mean using this train data. Whatever the mean you get, that's your real mean, and then train the model using this data and with this mean value. And then this is your unseen data. When you say unseen, you don't know, then we should not consider that. And then you apply the same into this, because these are the value you never know, but you are applying the, your missing value, whatever it learned from this, you are applying here and then try to predict. So if you are collecting the whole data, you are if you are considering the whole data and you are calculating the mean, it means you are giving some information to this section, right? So these 4 5s are impact to the mean value, right? Whatever you calculated. So make sure first, once you get the data, first split that. This should be step 1. This should be my step 2. This should be my step 3. And then you design your training. That's how it should be. Now, think of a partition scenario, as I was telling in the earliest, in my previous slides. So you have a data set and you have some undersample. You do not have all the different variation of data, and we wanted to create some what you say that cosmetic data. And there, what you do, that I wanted to regenerate, or I wanted to generate some data. So some people do what they just duplicate the records, right? The same record they enter multiple times just to make my data set a balanced data set. So I do this oversampling, and sometimes I do undersampling. So undersampling, oversampling is not point of discussion here. The point is, what I want to say is, if you're doing certain kind of this kind of thing to create your data, and then you're doing the random partition of train and test. So this random partition is the problem, because when it does the random partition, suppose think of my train data may look into this, and this record, and this record, and this is your test data, this data, this data, as well as this data. So when you keep this for test data, we already consider this record as my training data, right? So this is already, the system is already aware of this scenario. This is happens. So for these two records, it will predict very well, very perfectly. So this is not the right way to design. So I'm not going to talk about how to solve this problem. There are ways to solve it. But I want to tell you that whenever you're doing this, random partitioning is not the right choice to do that. The other one is we all use your cross CV, cross validation to make my model more generalized. So here there are two kind of problem I want to discuss here. That what you do that this is my this from this to this is my whole data set, right? From this to this. So I have fold one, fold two, three, four, five, six. So what I have done, I keep one fold with me. I use that as a test data, and I use these all data as a train data. But at what stage, how are you using this is more important, because people do what the same problem as I said of feature engineering. They already calculated the what you say your missing value, a mean. While they're calculating mean, they have already considered this. So even though you held out this already has some information from this section. So your cross validation will not work even though you do generalize, but certain, not always, but certain things when you do your mean calculation or scalar, standard scalar, those kind of stuffs, if you're applying to your feature engineering, then this is you'll definitely see the data leakage issue. The other is uh, feature selection, hyperparameter tuning. If you're doing and trying to find out the best parameter, so do not use the same folds for feature selection as well as hyperparameter. Use one fold for finding out hyperparameter, use another fold for feature selection. Or if you try to do, if you now think of how the cross validation works. So the cross validation works is that it will find out the score for each this pattern, and then you get the average, right? And then you get average score, and you think, okay, if the average score is fine, then you design and you take that model for prediction. Okay, this looks good, and you try to find out which is the best one. If it perform well, then you look into that. So but while doing this, if you try to get all feature selection hyperparameter for the same folds, then there might be a probability that it may influence your hyperparameter based on your feature selection. So it has to be also random. It should not do, sorry, I said random, but not, it should use different folds for different uh, feature selection as well as for the hyperparameter tuning, selecting the hyperparameter. So now how to avoid it? I have been telling you that the best way is split the data the moment you receive it. The moment you get the data, you split into train set and test set, and do not touch the test set. Make sure this is one way, but it is not all. It won't solve every problem, because if you have already during the data collection, even though you already have that value, like if you have your feature leakage, whether feature leakage, if a column is there, even though you split it, it is already there, so that won't have solve the problem. So there are other things you need to do, like check out the timelines of each feature, when this feature is going to come. So if this is my prediction I wanted to do, I'm right now, the business has come, so take about the life cycle of the data. The data has come from this place and it has gone and it is here. Now I wanted to predict what is the next step. So what, and in your past data you have everything, so you should take all the data whichever having only till this instance. So maybe only you collect the in the timeline only this data, because you want to predict this section. So you need to check if you're considering this column to predict, so it is in the future, in the real prediction you will not have this value, right? So and that's why you will not get that value. So it's always need to check that what is the timeline of each feature. The example I can tell, like think of a patient visited doctor, and doctor asked to check that, do the test, and certain test, after doing that they identify the person is having diabetes, and the doctor prescribes some medication, and suppose XYZ medication, some RX num code or some drug code to that, and that person has a record. So record has like patient ID, patient name, age, BP, systolic, diastolic, uh, any some other information, and these are the columns are currently null value, right? So because this is like any drug he is taking or any diagnosis is done or something, this information. So my business requirement is that if I am here, the patient still this information is that I wanted to predict that whether the person is really a diabetic or not. I have not done diagnosis, I have not done and not given any medication. I really wanted to check here, but in your data collection, you in your past data you have already everything. If you consider these values, then what will happen? Okay, this guy is prescribed with this medication. Okay, this medication means diabetic, so you, it will predict you diabetic patient is. But real life, this information not be available. So your model will work fine during your training and test, but it won't work in your real life scenario. So pre-processing, as I said, finding out imputation of missing value is one kind of pre-processing. So you should not do collecting with the whole data set. Rather, you do with only the train set. As I talked about feature selection, model tuning, model selection, you should do separately. You need to validate. Think of it as all are different models, and use different crossfold for finding out that. Uh, do top features correlation make sense if you are finding out the correlation metrics during your exploratory analysis? And if you see the relationship between target variable and with your other variable is really 100%, then you start thinking of that, is it really available to me during my prediction time? And at that time, your this domain knowledge and data exploration, when you do this time, you need to think about that whether really it makes sense to select one feature. And to maintain your code properly, it is always good to use pipeline. So the pipeline will make your code consistent, and it minimizes of data leakage issue. And also remove leaky variables. Leaky variables will be like, as I said, customer ID has some information. So do not consider those value, rather you get rid of those kind of columns. So this is the one of the example of wrong implementation of cross validation. I have collected my data X and Y. This is my target variable Y. And then I wanted to do some pre-processing like min max scalar. So I have applied to the whole data set, if you see here, X. And I got out my min max scalar. I do my transformation to all my variables standardization with min max scalar. Then I wanted to use logistic regression. Then I have this CV with 10 splits. And now I wanted to validate the score. But when I'm validating the score, I apply this logistic regression model and X and Y. But this X already has this information, whatever I have calculated from the test set also, because though cross validation split, but from that handout part also already having the some information. So it is a issue with of data leakage. So the best way is design your pipeline. I wanted to normalize the data, or so here I was showing you, if you see here, it is min max scalar. It doesn't matter. You can use your same thing, normalization scalar. You can use scalar here and use your min max scalar here and model logistic regression and define your pipeline. This is how it should do. Then in the same cross validation, and then while finding out the score, what I would do, I would just apply the pipeline. So what this cross-fail score does is here, for this X, I have not done anything. First, it will do what? It will keep aside my held out my last part or one of the fold, and it will try to do these two things. It will apply only to the trend set, and it will try to find out the score only for the test set. So it will automatically takes care of it. And so it's better way to write your code when you design your cross validation mechanism. So that's what it does. Now let's see some example and see that how it works with a demo. Uh, Let me end my presentation here. Uh, and then I should go to my Jupyter notebook. Here is my Jupyter notebook. Yes. So what we will see that during the pre-processing time, uh, what we do and where the problem happens, we will see what we discussed so far and how we can avoid that. How can you fix it? Um, so what I have done here is that I'm using here simple imputer to find out to do some kind of pre-processing. Also, I'm using standard scalar and some log loss to find out my score value and ROC AUC score. I'm also using numpys and pandas if required. I'm not sure about right now. Let's see that if I'm using somewhere, but I usually just put it at the beginning because I know I may use it. And then I'm just using this to suppress all my warnings, and I'm going to create a k nearest neighbor classifier. So I'm using a dataset Titanic CV CSV file. You can download it from Kaggle. It is available. So let me run this and then load the data. And then let's just see 10 records. Big heads will show me 10 records, or let 5 records. So let's want to see the 10 records. I see this. Now, as I said, this is very much important to look into your data once you load it and then understand the data set. Do you really understand all the columns or not? What exactly this column value holds? And this is the part of your exported data analytics. And you do more better if you know the domain knowledge. Try to understand that, okay, which data is available during what time. So because this is a past data, this is survived, P class, name, sex, age, and all these various columns are there. So I'm not going to talk about this metadata. You can understand from Kaggle or from internet. You can search about it. This is a very famous data set. And then I do as a part of my EDA. I'm just going to check something like here. I see here. 75% people are like age of 38, and the minimum age is like looks like an infant of 0.4 months. Sorry, zero point 0.4 month. I'm saying it's 0.4 months. Yes, exactly. Yes. Um, the average age is 29, so all looks like young, and the max age is 80. So also we can see that. Let me add that insert below. I'll just take this and dot info here. So if you see, this is my whole data. I have 891 records from 0 to 890, and I have 12 columns. And if you see, this column has 714 non-null values. It means some missing values this one has, and 889 has embarked, and some record might have some. I think 2 records has very few are embarked having missing value. This column has. So just because I'm using k nearest neighbor, I'm converting my categorical variables to one-hot encoding. So I'm making my, wherever the sex is male, I will assign 0, female is 1, and I just create another feature, uh, is female. And a similar way, if age is missing, I'm creating a age missing, and I'm categorizing this embark. If you look at, I might have if you go up, so these are like S, C, and M. I have 3 categories, S, C, and Q. So let me create this record. Now, if you see the features, I created this embarked is there, but I have already created these 3 columns, 0, 0, 1. It means whichever having embarked S, so it will assign the value 1 to that, and rest other 2 will be having 0. Similar to that, I have created each female. If it is a male female, then it will assign a 0, 1 based on the sex field. If it is a male, it is 0. If it is a female, it will assign 1. And this is what I have done so far. So we don't need this column. I don't need this embarked column because I already done the one-hot encoding of this. So I'm going to use this columns instead of embarked. So also we have the survived column as my target column. So let me collect the data here. So I have the data. Now what we'll do, I know that there are missing values, and also I'm gonna use standardizing this age column as well as my fair column, because I know that these two are not in the same scale, so I cannot do the comparison. So, and my system is scale sensitive, so I wanted to standardize it. So I will let me create this imputer two and the scalar, and then I just apply that. If you see why I'm applying, I created the object. I need to use fit transform. So whatever it learns from my data, X is, it will apply to that. And the transformation is the mean. Wherever I have name, not a number, missing values, I will apply mean to those records. And similar to that, the standardization it will do for age and fair. And now I apply that. And if I go here and check, now if you see, not a missing value we have uh, for the age column, right? So because I have done this, apply the mean to that. Also, 2 records embarked has some null value, but I am not considering that, but because I'm only considering this because everything has a value for this 891. If you see that 891 records, everyone has some value for that. And then I just want to see the score just to know that, okay, this is my mean. Also, same thing I can get through my scalar scale when I see this is the same mean I get. And it is just try to find out my standard deviation. And so what it does is that for the mean, if you see, it is your feature value minus of mean divided by S. So this S is standard deviation as well as U, and both has the values something from the test set, from your whole data set. This information is calculated. Now, similar to that, just to see this, okay, this is if you see after applying the imputer and the scalar, this is now my data got standardized. This H column as well as fair. So pretty much looks good. Now I have applied my pre-processing. Now let me split the data. So I have split my data and then build the model. So my model is ready with X train and Y train. And then let's predict it with my test set. So when I'm predicting with test set, if you see here, I'm calculating here the log loss and the area under curve. So if you see, I get 2.6 is my log loss and 0.8 is my area under curve. Now do the same steps, but right now what we'll try to do is that instead of doing pre-processing before splitting, we'll first split it and then we'll do the pre-processing and they'll see how the result is. And then let me load it again just to make sure I'm using fresh data, no impact from whatever pre-processing we have done before. And then I'm just running the same step. And again, I get that, yes, it is now 714. Same matching values are already there. And I'm not I'm not making any changes to this because it is not giving me, it is not transferring any information. There is no pre-processing that I'm using pre-processing as my finding out mean and the scalar. So that is not yet applied to that, right? So already I am missing and I'm not applied that yet. So then first thing what I do is this, let me split the data. I split the data, then I'm going to apply the mean and the scalar, and then I just copy the whatever the splitting I've done, I just keep it here just for the safer side. If you don't do also, that's fine. And then what I'm doing here, look into these two steps. So what I have done, I have already, what I'm going to do is that I splitted the data right now, right? This data is splitted. Then what I'm using that this X10, earlier I was using X, but right now I'm only using the train set to do the imputation and to fit the scalar. And I will find out the value for that. So whatever it gets, this object, whatever it gets as a mean and whatever it gets to the scalar information, see, I'm going to apply that thing to the test right now. So here, if you see, I'm using feeder transform, but here I'm only using transform because I just wanted to apply, don't want to learn that from the data. And then I design my model, same thing. I define my model with the k nearest neighbor. Of course, I just see that in this, what is that? Probably model is this, never. Why I'm saying that, because I here it is weight is using uniform, and weight is using distance. So let me remove that just to make it the same one. And then I will fit my model with that, with the trend data. Then I'll try to predict the same score and let's see that what it gives me. So I got this result of 2.6 and this information. So this looks pretty much closer, but let's see the difference of log loss of 2, which is this one, doing the right way, and this is the way where you done before, and just calculate the score. And you see here, you see there is a delta, right? And if you see the log loss is more in 2 because it is not, the loss is more because we have leaked some information at the first stage. And right now, without leaking, it is not performing that much what it was performing before. So it is very slight because I have taken a very lighter data set, and I wanted to show you that there is an impact. And but this problem though it is a small, but there is an impact on that when when the leakage happens. And the what is the kind of leakage you are doing, what is the impact, it depends on the data set, as well as what kind of model you are using, what kind of what is a transformation you are using, what kind of pre-processing you are doing, and lots of things. It can impact to your model in, when you define the model. So best practices is always split the data and do that, and all the things I said in my previous slide about how to avoid that, follow that. Hope you like that, and with that I am open for questions. Thank you very much.